1. Let's see if it keeps going here. Let's see here. Source. I just plugged it in. Was that the right plug-in? This one?
Just maybe press the source button again, maybe a second.
Maybe since we just put it on there. There we go. Okay, so see, that's what we'll broadcast to start with, but we don't want to see me. We want to see our lesson. Oh, bummer, huh? Let's see here. We want, instead of this, everything is disabled with this projector. I have to take everything off. There we go. Yeah, for some reason, every time I have it, it won't work. All right, so rates. You had many different rates that you dealt with at Sonora that you may or may not have known about. Okay, so we're using equivalent rates in the real world. You had to, when you guys planned to go to Sonora, there was one really important rate that you had to figure out. You know, what was it?
How much you had to pay?
How much you had to pay? Cost per student? Maybe? Okay, that's one. What's another one?
Kids to teachers.
That's the one I was thinking of. Kids to teachers, because did you have to bring extra parents along? Yeah, we had, so kids per chaperone. I'm a math teacher, so I don't know how to spell chaperone. So I like you said kids to teacher. That's good. What's another one?
Miles to minutes.
Miles to minutes. How long did it take to get there?
Students to dorms.
That's another one. Students to dorms. How many students per bed?
2. It was fun.
Well, was one per, but then you had how many per room?
Like 8.
7 or 8 per room. Now, within the rooms, did you guys, were you in many different dorms though? No, you guys all fit in one dorm? Oh, that was good. I've been to leadership camps up there. We had all the dorms filled out. So that was good. But those are all rates at Sonora. Student to teacher, students to dorm, student to room. When you ate, did you get to eat in the dining hall?
Yeah.
How many people sat per table?
Whoever
How many was in your group? But was that another rate? Students per table? Okay, so when we are comparing those rates, what were those 2 things that we're comparing? You know what those are called? Students per room. What are students and rooms called? Yeah. Units. Okay, so we're doing rates. We're comparing 2 numbers, but we're comparing 2 numbers of 2 different units. Miles per gallon. Is that one your parents are worried about? Yeah, that's a big one. Miles per gallon. So he can be walking from his house. He lives right over there. I know where he lives. He could save money on miles per gallon by walking to school.
That's true.
He's got to go to class, he says. So, and this projector just not helping me here. Everything's frozen on there. All right. So I'm gonna trick it. So every time I switch screens, I'm gonna have to take it off and put it back on. All right, so we got that part. Now, we said we were always doing students per teacher, teachers per room, or students per room, students per table. We're always comparing to how many? Yeah, 1. Okay, that's a unit rate. We're always comparing to 1. So when we're comparing, let's see, we want that, and It's supposed to, but I have to press the pen button, and the pen button is hidden underneath here. So I don't know why the projector is not working for me, but we will get it figured out. So unit rates, we are comparing. Yeah, it's not going to work. So we're going to compare to 1. Okay. So did a dot make? It's from my hand though. There. Yeah, it's for some reason the projector is freezing my screen. Yeah. Because as soon as I take it off, everything functions. Let's see if I can.
That's really connected.
Yeah, and see how the screen is,
Yes.
it's closed. Oops. Yeah, and then when I take it off, I get my whole screen with all my buttons.
Yeah. I don't know why that's happening.
I unplugged it now because now. Yeah. All right. We'll work this out. All right. So a unit rate, we're comparing to 1. So what we're going to do, we're going to do some unit rates problems, and we're going to do some non-unit rate problems. So the non-unit rate problems might be a little bigger. So do you guys have something you can work on?
Yes.
Whiteboard? Let's get those out. We're going to start using those. You never get to use that?
Do you want to just put into the dock camera?
That's what I was going to do. I'm going to flip this over and put it under there and do it that way.
I don't know why this isn't.
It's a different project. We have those BenQ ones, so I don't know if that's. But I was thinking that would be the other option is to do it this way. I actually did this at Fort Washington too.
You did?
For kindergarten class there. Okay, we're going to trick the computer. We're just going to put it underneath the camera. So we're going to do it that way. So I have to sit down a little bit more, but we'll make it work. So a unit rate. So we said units when we are comparing to 1. Okay. So if I ate, it still doesn't want to work. It is just not working today. My goodness. I know, I tried there. That was old. Alright. Ready for a unit rate problem. Okay, so here is an example. We have, let me move this out of the way here. There we go. We see that one all right? I'll put it right there. Okay, so we can even zoom in a little bit if we need to. There we go. So there are 150 students at this middle school. 2 out of 3 prefer gel toothpaste. And we want to predict how many students in the entire middle school prefer gel toothpaste. Okay? So the unit rate problem's at the end, but we'll come back to that. So, what are some of the things we need to know before we can solve that problem? Yes?
How many students there are in all?
How many students there are total? Do we know how many students are total?
Yes.
Yes. How many are total? 150. So that doesn't want to work. Okay, so the 150 are total. What part of 250 are we trying to find? 2/3. So Going back, using the R word from before. What other R word did we have before rates? Yes. Ratios. So 2/3, we're trying to get it to equal something over 150. What's that called when we have two ratios that are the same? What are they called? Like 1/2 and 2/4 are called what?
Fractions.
Fractions, but what type of ratios? Equivalent ratios. Okay, so if we have 2/3, and then how are you going to make an equivalent ratio so you can find that goes with 150? Remember how? Yes.
You can do division.
You can do division. How could you do division?
You do how many times does 3 go in 150?
Okay, and then what would you have to do?
And then you would get your number, and that would be every 1/3. So then you do that number plus the whole times 2.
Times 2. Very good. Now, is there only one way to do it? No. What's another way to do it?
You can multiply you can divide 150 by 3 students, and then that would be the bottom number, and then 50 times 2, 52
Okay, that's kind of the same. Does anybody think of a different way to do it? There's many, many different ways to do it. And is it okay if they're all right? Yeah. So see if you can work that problem out. And I'm going to show you 3 different ways. The one way they showed, go ahead and work it out. The way he showed, I'm going to show 2 different ways too.
All right, boys and girls, give it a shot on your own, and then Mr. Berg is going to show us 3 different ways. Do it the way you think you know how to calculate this problem to the best you can.
Okay, I'm going to restart this thing and see if I can get it to go. All right, so did anybody find a way different than these 2 guys set up? I'm going to shift out of here. Oops. I'm going to trick it. We're going to trick it 2 times. We're going to trick it out of this program, another one so I can still write right on my computer. Go here, here, there, because the other 3 programs all run. Oops. Something with that projector killed it. All right, come on. Oh, what was the answer? What did you get?
Yeah, 100 over 150 equals 1/3.
Okay, so 100. How many did you get? 100? Didn't finish? What'd you get? You're still working? All right. I'll give you a minute while this is still coming up here. I see a lot of good answers. I see some nice flowers on a couple.
He's going to show us 3 different ways. Like that.
Any students? Okay, so we had 150 students. Okay, so we have 150 students. I gotta zoom out. And we want 2/3 of those. So, okay, so what they're talking about, they both said we had to divide by 3. Okay. Okay. So they said we had to divide by 3. That's still on the screen? Almost. Piece of paper. So they said if we divide by 3, we got how much? 50. And then what was the next step? Multiply by 2, and they got 100 students. Okay. So think of that in terms of a fraction. Okay, if we had 150 students, okay, and we divided it up into 3 parts, we'd have 50, 50, and 50. So what part of that did we want? What part of those 3 did we want? Yes? 2/3. So if we just add 2 of them, let's do... So if we only wanted 2 of those, okay, now do we have 100 again? Okay, is this way different than this way? Kind of, a little bit, not a whole lot. Now, when you were solving your equivalent ratios, did you do something called cross multiplication?
Yes.
Yes. Could you have done cross multiplication to solve this problem? Yes. Could we have done x over 150 equals 2 divided by 3? 2/3. So when I cross multiply, what parts do I cross multiply? To 150 and what? And 2. So these 2 multiply together. And what's the other part that multiplies together? Yes. Yes. X and 3. So we have 3x equals, what's 150 times 2? 300. So when we divide, x equals 100. So is that a third way to do it?
Mm-hmm.
Yeah. Did anybody else find a different way to do that problem? Okay. Did anybody find a different one? Okay. Perfect. Good. So here's what she did. Oops. Okay, so I know. So what she did is she made 2 fractions. She did 2/3 times 150 over 1 and multiplied. So 300 over 3. What's 300 divided by 3? 100 again. Okay. Again, is that the same? Okay, so did we find the answer 4 different ways now? Yeah. Did anybody else have a different way? No. So is there always one right way in math? No, there might always be one right answer, but there are many different ways to get to that answer. So whichever way works best for you, that's the one you should try. So let's see here. Yes.
Can you go back? I had a student ask me on yours why you put the X on top. Did you want to?
All right.
Like I said, why is the X still on the bottom?
Okay, so why did I put the X on top? Right here. Is this where the question was? Okay, so 2/3. Is 2/3 bigger than 1 or smaller than 1? Smaller than 1. So when we're talking about these students at the middle school, are all of them going to have, what was it? What was the question?
Gel toothpaste.
Gel toothpaste. Do all of them use gel toothpaste, or more than all of them use gel toothpaste? Yes. Yeah, do more or less than the total? Less. Okay, is 2/3 we said is less than 1. Okay, so we know that this number is going to be smaller than 150. So since 2 is smaller than 3, the number of people that use gel toothbrush is going to be smaller than 150. So we always want our smaller values, our bigger values. Now, if this were the other way around, if it were 3/2, then we'd have to put the 150 on top. That have you done percentages yet? Last year. So if you did percentages, remember it's is over of equals percent over 100. Remember the smaller value is the one that goes on top. Okay, so we have that one. Can we go to a little bit more tricky, a little trickier one?
Yeah.
All right. So let's go back. And while you're working on the trickier one, I am going to restart. I'm going to trick it again. I've got lots of ways to trick the computer, so I'm going to trick it into working, I hope. All right. Okay, here's a. That's right. Sisters always send more text messages. There. Okay, so the ratio of number of text messages sent by Lucas to the number of text messages sent by his sister is 3:4. Lucas sent 18 text messages, so how many did his sister send? Okay, so is this a rate problem or is it an equivalent ratio problem? It's a ratio problem. So let's see, this is an easier one because we're going to make it a harder rate problem here in just a minute. So is there only one way to do it again?
Nope.
Nope. What'd you get?
I didn't show you.
You didn't start it yet.
Not necessarily.
Is it Oh, yes, you're right. So, basically, yeah.
And so,